Great. Well, thanks, everyone. I'm really excited to be talking with you all today. Is this good? Oh, I'm on this laptop here.
Is this my laptop?
Go ahead and take it.
There we go.
No. One more. One different one. There we go. All right. Thanks, everyone. Sorry if my throat's a little dry. Really excited to be talking with you all today. I feel like I'm, sorry, literally parachuting in to a completely different community than I've experienced with. My first time seeing a drone show was at Burning Man in 2019, and it was the most otherworldly thing. If any of you haven't seen one, like if you didn't see last night's or haven't seen one face-to-face, I'm sure all of you have, but it's like one of those, like, is this alien technology or not kind of moments. So really happy to be talking with you all. I also believe that there's a lot of the things that we're working on in the Open Source Security Foundation that might resonate with many of you who are working in regulated industries, who are perhaps selling to government and lots of different governments, and thinking hard about the issues of trust in open source code. So thought I would come at Ramon's invitation to talk with you about what we are doing in the OpenSSF and see if we can't get you all somewhat involved. But I want to talk first about the nature of trust. Why do we trust open source code? And I would argue that it started actually older than this slide, which is a capture from the Internet Archive of a website called Netcraft. The capture was from 99, but they actually started in 95, doing a complete survey of the internet, pinging every IP address, every DNS host name they could find to see, are you running a website? And if they were, what software are you running that website on? And they, since literally the dawn of the web, had been building a monthly snapshot of what server was running. And in, I think, April of 95, oh no, sorry, January of 99, when this was taken, the most popular website was, or web server software was Apache. And it was really the first time that the world had quantitative evidence that open source code was being used in production. Right? It was the first time they could see that and prove to their bosses, that as developers, many of us were playing with Linux, we were running print servers and DNS servers and websites, but it was hard because aside from Red Hat and a very small number of other companies, there wasn't really a claim to be made that this was, suitable for production. You could pay someone a support contract. It was like, it was okay to use compared to Microsoft that had, 10% of the market share that Apache had. And literally, the other cool thing about that site is you could type in a URL, a host name, and it would tell you, oh, that's running Apache, that's running NCSA or whatever. And we could literally show, hey, if you can go to CIA.gov and see that it's running Apache, and if you could go to Vatican.va and it was running Apache, and it was easy to make this case to the pointy-haired bosses that if it's good enough for both simultaneously, the CIA and the Vatican, it's probably good enough for your website. But it was great. After that point, there was kind of an inflection point in 99. That's when you started to see IBM taking out Super Bowl ads, talking about Linux. That was kind of a pivot point. But we also, it caused us to also make the case inadvertently. Because a lot of us were like making the case, well, you can trust open source code, when there were a lot of other companies saying open source is cancer and it's coming from unknown sources. Can you really trust it? And we kind of won the argument based partly on market momentum, but I think we also inadvertently made the argument that popularity was a proxy for or even equal to security. You can trust it because everyone else is trusting it. But But the second reason why I think we earned a reputation for trust in the open source world is that many of the early open source communities rightfully started to focus on the contribution process. In Apache, in the Perl community, in the Linux community for certain, all of those communities, even if they were ad hoc processes, even if they were still enforced sporadically and depended quite a bit upon either heroics or uneven enforcement, they all developed contribution and project acceptance processes, and really the better ones tried to focus on community over code, on pulling together, not just asking, hey, is this good looking code, but has it been vetted by other people, right? Generally speaking, Apache Apache wouldn't make a source code release unless there was at least 2 other people signing off on the tarball that somebody had made, saying, yeah, this really does look the same to me as the same body of code. Actually, generally speaking, Apache used to never ship binaries. They used to only ship source tarballs and leave it up to you to build. Just as, again, a kind of a validation of that trust and that community process. And I think it was important to helping people get across that it was a community building code, but it seems like we went kind of sideways from then. It seems like in the last 10 years, and I hate to be like the old man standing out front of the house yelling at the kids, get off my lawn, but to some degree, we have seen obviously the explosion of open source software, which has been great, the ease of forking projects, which has allowed for hundreds of millions, I think, or tens of millions at least, of projects on GitHub and other major repositories, but an awful lot of projects that have one developer behind them. In fact, a recent survey of projects in the NPM community showed that the median number of developers on an NPM project is 1. The vast majority of projects in NPM have 1 developer who's thrown out 100 lines of code or more and said, here's an open source project, have fun. And this swap meet model of open source, where you just have thousands and thousands of different individuals kind of selling or giving things away for free, but without a lot of resiliency that comes, is not only bad from a security point of view. The whole like Linus's law, which was actually not anything Linus said, but was something Eric Raymond said Linus said, which was that with enough eyeballs, all bugs are shallow, only works if you have enough eyeballs, right? And generally speaking, that means more than 2. And really, this is something that I think has led to, if you look at recent kinds of compromises and vulnerabilities, things like the colors.js situation where a developer felt underappreciated because their JavaScript module is being used by hundreds of thousands of websites out there, and he was kind of burning out, and no one was contributing patches back into him or helping him fix things, and yet they were getting angry at him about things that were broken. Not only does it lead to security issues, it leads to burnout issues and sustainability and viability issues, all things I'm sure you're all thinking about when you think about how to maintain especially the most core components of your repositories. And that's really out of a sense that the ideal model for an open source project isn't a mere aggregation of thousands of one-person projects, but something that looks a little bit more like a barn raising, where a group of people get together to do a thing that none of them can individually do, even given an unlimited amount of time, right? Physically, one person cannot lift up the frame of a barn, but get enough people together, even on a voluntary basis, and you can accomplish a lot, even in a day or 2 of them. And this matters in the open source community, not just for kind of our major projects, but really, with apologies to turtles, we should be thinking about how to make open source barn raisings all the way down to the frameworks like Kubernetes, all the way down to their dependencies, down to the operating system layer, and arguably down to hardware. This is obviously why at the Linux Foundation we have projects like RISC-V and others that try to argue that, hey, this matters all the way down. So rewinding back though to why that second step of how we gain trust in open source, it was really just about trying to make the argument that despite luminaries and gurus like Linus and other things like that, it was much more about the processes. It was much more about enough eyeballs and that resiliency. And when you think about it, that was also a place that was able to tolerate and enable pseudonymous contributions. There were people who did not have, contributors to open source projects did not flash their passport to prove to you their nation of origin, right? They did not strongly authenticate themselves in ways beyond just their email address, maybe. This was one of the really unique spaces where you could actually trust pseudonymous or even anonymous contributions and allow people to come in and be productive and then depend upon their code. Another story from the early days of Apache was a contributor named Alexei Kostet, who had been like a model contributor for 3 years, always the kind of developer who would write clean code, but more importantly, help other people review patches, answer beginner questions on the Usenet news groups. And then he sent a letter to the other HTTPD maintainers saying, hey guys, I'm really sorry, but I'm going to have my contribution level is probably going to dial down a little bit in the fall when I start as a freshman at Stanford University. And the fact that a high school kid could make substantive contributions as a peer to others, I think was essential to open source's success and our ability to trust that, because we trusted a mix of his contributions and code and who he is, but also trusted in the process. And when you think about it and about the direction that so many of our internet forums have gone, we're one of the last such places where we can effectively harmonize and make use of contributions from a wide array of differently authenticated sources. In fact, recently I was asked by the House Committee on Science about how we keep bad actors out of open source projects, how we make sure that people from certain countries aren't slipping backdoors into code. And I pointed out that last year, the University of Minnesota, as a research project, I don't know how this passed their review committee, but as a research project, decided to prove how fallible open source contributions processes were by submitting a backdoor as well hidden as they could into the Linux kernel, which made it through a few rounds of review. I don't think made it into Linus's tree, but made it into one of the other major contributors' tree. But it was found after about 5 days, excised out of the contribution stream, but not before wasting a lot of people's time. They caught it, and from that point forward, the University of Minnesota has, and to this day still and forevermore, will be banned from contributing to the Linux kernel. I hope that the congressman I responded to was not from Minnesota, because otherwise that would be bad. I'm not sure I could set foot in the state. But it was a sign that, again, it's more about the processes and the community than it necessarily is about the individuals, but individuals matter. So with this as context, a lot of the work that we're doing at the Open Source Security Foundation isn't about just like finding vulnerabilities in code. It isn't about like trying to hammer on people you should write more secure code. It's about a systematic approach to understand how we can improve the way that the open source community writes code and builds upon other dependencies and try to move towards very objective tools to measure the trustworthiness of code, both of contributions, but more importantly of the software as it exists. Try to encourage processes that tend to lead to more trustworthy software, more secure software. And try to look at tools and processes that encourage teamwork and shared responsibility for security within open source projects. Whether or not you believe one-person projects, one-person repos are okay, there's got to be ways to be able to, when you pull these together and aggregate them, get to trustworthy systems. And by the way, none of this is going to be successful if we stepped into a community and said, thou shalt, or you need to, or here's a whole lot of extra work. All this stuff needs to be as possible, as low lift as it can be made, add a by default to all of the above to whatever degree that you can. So I don't have quite enough time here to go into all of the different rings of the circus that we have. It's at least a 7 or 8 ring circus, but it touches on things like better development practices through contribution guides, through education materials we've put up on edX about how to write more secure code. It has to do with better understandings of how to coordinate vulnerabilities, disclosures, and handling processes within the open source community. It does involve a couple of software projects, one of which is called SigStore, which is about trying to get digital signing of software artifacts throughout the software supply chain pervasively adopted in the open source community. All sorts of different things, but let me actually give you a bigger frame for how we've now, just this year, started to organize our efforts. And by the way, it's with the help of a whole lot of big companies and startups and companies that are deep into software supply chain, but also plenty of end user organizations as well who have big stakes in building more critical and reliable software. But now I want to pivot and talk to you about what has really started to drive a lot of our work in the last 6 months, which is the development of something called the Security Mobilization Plan. And it kind of begun when, in December, the vulnerability called Log4Shell was released. And by the way, I hate calling it the Log4j bug, because Log4j is the name of a piece of software with some professional developers behind it who did their best, made a small mistake that cascaded into a rather large thing, and they don't deserve to become, the example, right, to be made of. But it was really the Log4Shell compromise with that started to drive everyone to wonder, are there some deep problems with how we write and deploy code in the IT industry, in the open source community? In fact, it caused folks who we don't normally hear from, like the National Security Council, to ask us by convening a meeting, which, by the way, if the NSC invites you to a meeting, if you aren't expecting it, isn't always a good thing. But they had been looking at this topic of critical infrastructure for a long time. In fact, back in May of last year, the White House issued an executive order 14028, which called for the adoption of a set of security practices across all of the federal sector, including the adoption of software bill of materials, and I'll get into that in a bit. But they basically put a call out to a set of companies, as well as Apache and Linux, and invited them to a meeting, the framing of which was, are you all okay? Like, there seem to be these earthquakes that hit on a fairly regular basis, and it's as if, they didn't put it this way, but I would, bridges and highways, were falling down a couple of times a year, and you were just standing there and going, well, I guess we'll set it back up again. Like, there's gotta be a better way, right? So we had a 6-hour conversation over Zoom, and fun, right? That led us to basically a framing, sounds trivial, but like, maybe industry and government, and not just the US government, there's other governments obviously who use software and have a stake in this. Maybe we should be thinking about, in the community, thinking about ways to better secure the production of that software, improve the way that we find those vulnerabilities and remediate them, and then really find ways to accelerate the rate at which fixes make their way to production. There were so many companies who, when the Log4j debacle hit, Log4Shell debacle hit, who said, well, don't worry, we're not vulnerable because the bug was found in Log4j 2.x, and we're running Log4j 1.x, which is obviously not vulnerable. Well, it had been out of support for 5 years. I'm the kind of person who thinks when you end support for a major stream, you should issue a proactive vulnerability notice about it. There might be bugs here, you better upgrade. But that's the story. So in response to this, the OpenSSF community kind of hunkered down and said, given these kind of goals and obviously what we're doing already, which like every open source project, you kind of do opportunistically, right? You guys put out code and you hope people consume it and you hope people kind of build products and services around it and contribute back in. Every open source project at the LF or out there is kind of aspirational in nature, kind of opportunistic in nature, kind of, hey, if it turns into a thing, great. This was a little bit different of a top-down mandate. It's like, given these problems we've identified and given what you're doing or could be doing, how do we close some of these issues inside of the next few years, right? How do you have a measurable impact inside of a reasonable amount of time and not just hopium, right? So we started to think about what are some pre-existing efforts that could be used to address many of the kind of gaps that came up in that meeting. Are there ways to double down on those efforts? And then what are some targets that we might set to have, a double-digit % kind of impact on this? Could you close up 75% of the risk that comes from one kind of weakness or another? And then what kind of targets would you hit? So we pulled together, we kind of identified 10 different thematic kind of areas, and I'll roll through them very quick, and came up with a set of things that we're doing today that kind of address them and things we could be doing to add to that. It was not with a money is no object kind of thing, but it was kind of with a, if you had enough resources, how would you go and tackle this and what would it cost? Like what's the next order down kind of, resolution on the minimum viable cost to kind of make something like this happen, presuming that once you get started, you'll find lots of companies that'll help, lots of volunteer organizations, and lots of ways for people to fit in. But often on these kinds of initiatives, you need a core, you need a kernel, you need a few people to get things started, or some project management at the very least, or sometimes just some raw funding to get some things to happen. In that January conversation, we had set the expectation that, this is probably not a tens of billions of dollars problem, but this might be hundreds of millions, or maybe single-digit billion. It's not going to be a $5 or $10 million problem. The good news is, and I'll walk through again what we came up with, we identified about $150 million worth of funding over 2 years that would address the first 2 years of this plan. I rolled it out in May at a meeting that, again, was kind of a follow-up to the January meeting that the White House brought the National Security Council, CISA, Office of National Cyber Directorate, folks from the Department of Energy and a few other agencies, and we brought an even larger collection of open source projects and our commercial community members and the like together to talk about this plan, talk about enhancements, improvements to it, and then, but really also to start to identify who's in to help fix this. We were not there to ask the government for money. That's not how the US government spends money. They don't just, have a meeting, you walk in, hands open. Well, maybe that happens sometimes, but not so openly like this. We said, said, we just want to tell you what we're doing. If you find ways to align what you're doing with what we're doing, that's awesome. But at the very least, we'd like to make sure we're not overlapping efforts, and let's see what happens. Through the course of this event, our other community members, the commercial participants, said, we'll put at least 30 million towards this plan, and that was really just a start. So we're in the process of identifying more of the rest of that gap. I'm gonna go a little bit stream by stream. It's not with enough time to dive into each. I probably have about 30 seconds here per slide, so deep apologies for this, but the plan is available on the website. You can read more about it. I also don't want to build it up to be like the Bible or the totem. It's not like the end result. It is version 0.9.1 to indicate we've made a bunch of progress, but we're still refining many of these plans. But to give you a kind of a brief kind of overview of the 10, the first is focused on education. How do we help developers write more easily defendable code, more easily securable code? How do we help them understand where software has been compromised before, the kinds of dirty tricks that black hats like to use to get inside, as well as things like don't parse externally contributed input for format strings, which, in all honesty, as great as the Log4j developers were, had they listened to that, they might have built what they built a little more defensively. So with this, we've got content ready to go. We just need to get it out there, but we'd also like to find ways for people to prove that they've taken that course in a very lightweight way so that people can start to say, here are projects that have been built by the people who understand some of the basics, right? The second is around risk assessment. How do you know that one project over another is more secure than another? What are these objective measures? Things like the security scorecard project we have at OpenSSF, which scans code bases for the use of, obvious things like testing and things like dependency locking and the kinds of things that tend to lead to better security, as well as things like who's recently been third-party audited or who's had their dependencies have vulnerabilities in them. So pulling that together into a place to easily say, hey, I want to use a Java web framework. What are the ones whose practices and policies in aggregate tend to score better? These days, all you tend to have are number of comments in the Reddit forums or stars on GitHub or other much more basic measures. So hopefully this will help us get more quantitative about where risk lies as a way to help open source projects improve and score better. The other I mentioned, Project SigStore, we feel is pretty important to get integrity through the supply chain from having signatures attached to each of the individual components as they flow through. SigStore has started to get a fair bit of traction, especially in the cloud native community. It is not only limited to open source code, it is something that could be used for all types of software artifacts, and it uses a very lightweight identity proofing system very similar to Let's Encrypt. And so our hope is that the same way that Let's Encrypt helped us actually encrypt the majority of the web today, that approaches like SigStore would help us get there as well. Another major component that we identified as an opportunity to do better is to eliminate entire categories of software vulnerabilities like buffer overflows and other memory corruption issues through the use of languages, particularly more modern ones like Rust and Go, that have better memory safety as a built-in language feature. And so there are proposals out there to rewrite, actually efforts underway already that we would put more resources into to do TLS libraries like Russell's or DNS and NTPD, like these other forgotten kind of like internet infrastructure types of utilities into languages that just have better type safety and hopefully eliminate categories of weaknesses. We felt as well, you can't go to open source projects who are under-resourced or have developers who are earlier in their careers and say, here's a guide to coordinated vulnerability disclosure, have fun, because figuring out how to take a CVE and get to a better place than a massive industry disruption is hard work. And so we feel, and looking back at previous major incidents that caused a lot of issues out there, we felt having an incident response team, a volunteer firefighter kind of crew comprised of software security and software development experts on call, essentially, on duty, to step in when a small team hits a bug they they can't handle themselves, who can, on a confidential basis, help work with those maintainers to get to a coordinated release, who are bound even to keep things confidential from their employers, to avoid the perception that this is a private zero-day club or something like that, to basically get to a point where we can help those projects. That was a big part of stream number 5. Stream number 6 is about, kind of think of it like an open source version of Google's Project Zero. Like go and systematically scan the top projects, the top 10,000 projects for new kinds of vulnerabilities. For, you know, whether it's using, I'm sorry, what's the tool on GitHub for scanning code, query something. Anyways, use a bunch of off-the-shelf tools, perhaps even stuff that's de novo written, but have the operational infrastructure and the team who can help take whatever is discovered and confidentially manage that with open source communities to get things fixed. Code audits. Code audits, has anybody gone through a third-party code review of your open source project? If not, it is incredibly helpful. It's incredibly helpful to have a set of eyeballs, if they're pros, if they are the right kind of auditor, to go through and not only look for like the off by one errors that could be buffer overflows or the typecasts that don't make sense, that could be problematic, to your architecture, to your feature set. Did you mean to put that chainsaw in the middle of a dinner cutlery set? And did your users expect what happened when they picked that up while it was running? You know, those kinds of things are incredibly helpful to an open source project, and if done right, can help find not only lots of unknown vulnerabilities, but lead to more resilient software. So what we propose is funding eventually 200 of these. It sounds like a small number. These things are expensive. They can run on the order of 200 grand to do it well for an average size project. Obviously less for that one person 100-line code project, but to try to identify the most critical kind of infrastructural or platform types of projects, go and do this work and do it every year for different projects, but sometimes even for the same project if you get a lot of code churn, to try to bring that extra level of protection. 3 more, apologies. One has to do really with sharing of information about what are the critical, how do we determine what are the most critical projects out there? How do we know when something's being used or if something's being depended upon? There's a lot of public data we can consume about that, but there's also data that comes from the software tools makers, from places like GitHub and others that would help us figure out where is the next forgotten about and under-resourced component that we all didn't realize this, but everybody depends upon. This is a stream to help focus on that and set up a collaboration amongst the source of this data to do joins across it and come up with better data, like the data we created in the work that we did with Harvard on something called the Open Source Survey, which was discovering criticality scores for the top open source projects. The stream 9 is about finding ways to encourage adoption of software bill of materials pervasively across open source. The further up the stack you can go, the further left you can go into getting generations of software bill of materials by the tooling itself. And the easier you can make it to aggregate this on the way to the finished work, the less burden it is upon the last mile. An SBOM is a software bill of materials. It's a document that comes along with a package that describes where it came from and what's inside and a few other bits of metadata. It's really useful when you have a vulnerability that's announced in package X, and everybody scrambles to figure out, are you affected by package X, right? It's useful in the same way, like the metaphor I use is, you know, when you buy a bottle of ketchup at the store, or you're trying to consider whether you want to buy a bottle of ketchup at the store, it has the ingredients on the back. And if you're allergic to paprika, then you know not to buy the bottle of ketchup where it says paprika is an ingredient. If you didn't have that, you're kind of just flying blind, right? So this is a way to try to help people understand where they might be susceptible to a vulnerability. It's table stakes, right? But it's a key part of something the US government said we're going to start to require from everybody selling to us to provide SBOMs. And I'm sure many of you are being asked to provide it to your customers, and you're sitting there having to assemble it from this mass of other underlying dependencies you have. We want to push that generation upstream, make it built into the tooling by default, so that it becomes an easier lift for all of you who have to deal with it at the tail end of the supply chain. Finally, we think there are some important things that can be done by bringing the folks together who run NPM and PyPy and Maven Central and the kinds of last mile large, what are essentially app stores right, for open source code to harmonize processes and things, everything from adoption of signatures and standards like SLSA, which we call SALSA, which is for communicating levels of trust through in the build processes and managing risk and deciding, am I going to deploy this based on where it came from, to things like harmonizing multi-factor auth approaches across, those, especially for the critical projects. This is work that is perhaps the hardest to estimate, partly because it deals with that mix of open source code and commercial services. But there's obviously lots of open source kinds of distribution points at the very end too. So all these put together, and I apologize for running over time, I'm pretty good, lead to $150 million in total spending for 2 years. We're not going to start all of these at the same time. We're going to start some of these streams before others as they get funding, as they identify themselves as like ready to turn cash into better security, and the right stakeholders are found around them. Some of them are very shovel ready, as it's called. Others take some more time. We already have $30 million in pledges towards this work, as I mentioned, coming from Amazon, Ericsson, Google, Intel, Microsoft, VMware. We do expect another batch coming in, let's just say before the end of the year. And $150 million might sound like a lot, but a larger number that I'd put in front of you is $700 million. Does anyone know what number I might be referring to there, what that number might signify? Sorry. Well, I gave the answer away, sorry, before you could raise. This is the fine that the Federal Trade Commission levied on Equifax for the 2017 data breach caused in part by unpatched open source code, by an unpatched Apache Struts installation on one company for one breach, right? So our hope is that we can make the case that $150 million is an ounce of prevention to billions of dollars or more of cure, because partly because the FTC, even just focusing on the Log4Shell issue, have said anybody who suffers a data breach, who we find liable for that, who has not upgraded a vulnerable instance of Log4j, we're going to levy additional fines as a way to, that's like the sticks part of the motivation to get upgraded out there. There's a whole lot of carrots out there. We hope to provide more carrots, more incentives for people to get better, but sometimes you need the stick too. So get the plan, get involved with OpenSSF. If any of this sounds relevant to the work that you're doing, I in particular want to see us move. We really have a lot of active involvement in the cloud community. We have folks starting to knock on our door around embedded systems and upgrading, edge devices in the field and the like. I feel like all of you perhaps have the same concerns we do about vulnerability of devices and underlying security. Get involved in OpenSSF. Lots of different ways to do it. I will hang around here. Try to find me if. But really, we are an open book. Come to our Slack. Come to the calls that we have nearly every day. Get involved. We'd love to see you. Thank you very much.